Welcome to the Slop Temple. We pray this video helps.
You start by gathering what matters: a camera that captures 30 plus FPS and a GPU for model training. Once you have that, set up Python 3, 8 plus, OpenCV for preprocessing, and PyTorch or TensorFlow for modeling. Make sure your data is consented and labeled. You will need balanced classes and augmentations to improve robustness. Then install dlib or MediaPipe for landmark extraction. Now prepare a small pipeline script that ingests video, detects faces, crops, and saves aligned images for the next step. Once done with aligned images, build a detection to embedding pipeline. You extract facial landmarks, align faces, and feed them into a backbone network to produce embeddings. Train using triplet loss or arcface to separate identities in embedding space. Hard batch mining and augmentation improve convergence. Make sure to hold out validation identities and compute true positive and false positive rates so you can choose an operating threshold. Also evaluate across lighting and pose variations. After training, export a lightweight model for inference and quantize if you deploy the model as a service, REST or gRPC, optimized with ONCs or TensorRT for low latency inference. Make sure enrollment creates stable templates and matching compares embeddings with a configurable threshold. Log decisions for audits. Once live, run real-world tests focusing on occlusion, pose, and lighting to detect failure modes. If latency or accuracy is off, profile the pipeline, reduce image size, or quantize the model, and retune thresholds. One key troubleshooting tip: if false accepts increase, raise threshold and reevaluate on balanced validation data.
Thanks for watching. Consider subscribing if we helped you.